Okay, this is the P2 paper from June 2021. This is question number 9, which, as we can see, is a differentiation question. We're going to do some differentiating to find stationary points and have a look at some minimums here. It's also modelling with differentiation for this top bit here. So let's have a look at the question and see exactly what we've got. It says, figure 3 shows a square-based open top box. We've got L and L as those two lengths there and a height H. And what they're asking us to do, they're going to give us the volume of the box and then ask us to see if we can work out the surface area. Notice in this surface area equation, L, it doesn't exist. So this is a relatively standard thing to do, that I'll use this information to be able to work out what L is in terms of H, and then substitute that in there. Now, just in terms of your exam craft, even if you can't do part A here, you should still be able to go on and hoover up the marks for part B and part C. But let's see if we can have a stab at part A as well. So it's a volume of a box. The volume of a box is obviously base times width times height. So in this case, that's H times L squared. And we know that that is equal to 250,000. So as I said before I even started looking at this, I can see that there's no L's in this formula. So what I want to do is to get L in terms of H. So that's given me an idea about what to do in terms of my method. So L is 250,000 divided by H. Sorry, L squared is that. So L is the square root of all of that. The square root of 250,000 divided by H. And actually, the square root of 250,000 is 500. So it's 500 over root H. If you want to write that as 500 over H to the half, or 500 H to the minus a half, it doesn't matter when we're going through and doing it. They're all the same thing so far. So I now need to find a formula for my surface area of my box. So let's just have a look at it. I've got the square base there, so L squared, but then all of the other 4 areas are going to be L times H, L times H, L times H, and L times H. So if I'm trying to work out the surface area, then it's going to be L squared plus 4LH. It's an open box, so not 2L squared, just L squared. Okay, well, don't forget now we know that we want the formula that doesn't involve L. Well, I've got L squared up there, so that makes things even easier here. This is going to be 250,000 over H plus 4H, or 4LH, but 4, okay, 500 over H to the half, times H. Well, if we tidy that up then, that's going to give me 250,000 over H plus, now this bit here is 4 times 500 is 2,000, and H divided by H to the half is H to the half, or H to the square root. So it's going to be 2,000 H to the half, and then finally, what did they have it as? Yeah, they had it as square root of H, so S is, do it exactly like they've got it, yeah, that's fine. 250,000 over H plus 2,000 root H. So that's part A done. And as I say, even if you couldn't get that part, you can still go on and do part B and part C. What are we asked to do? It says use algebraic differentiation to show that S has a stationary point when H is equal to something or other. And we've got to find out what that K is. Well, I know how to do stationary points. Stationary points, so part B, start with my formula, S equals, now I'm going to write this in terms of something I can differentiate. So it's 250,000. So 250,000, not 250,000 over H, 250,000 H to the minus 1, and the 2,000 I'm going to write as H to the power of a half. Differentiating that then, ds by dh is going to give me, multiply by the power, take 1 off the power, so minus 250,000 H to the minus 2. Same thing with the second one, multiply by the power, take 1 off the power. Multiplying 2,000 by a half is going to give me 1,000. Taking one off of a half will give me h to the minus a half there. And then we know at stationary points, in this case ds by dh, but the differential is equal to 0. So I'm going to get this equation, minus 250,000 h to the minus 2 plus 1,000 h to the minus a half is going to be equal to 0. So I just need to rearrange this. So I'm going to take this over to the other side there. So I'm going to get 100 h to the minus a half. Well, let's tidy up that at the same time. 100 h to the minus a half is over that. And 250,000 h to the minus 2 is over h squared, like that. So if we multiply everything by h squared on that side, h squared, I'm actually going to end up with 1,000 h squared over h to the half equals 250,000. But h squared over h to the half is h to the 3 over 2. When you're dividing by powers, you just subtract the powers. And 250,000 divided by 1,000 gives me 250. So I've actually got then, if h to the 3 over 2 is equal to that, then when we're doing that, if h to the 3 over 2 is equal to that, h is equal to 250. We're doing the inverse of it, so it's going to be h to the 250 to the power of 2/3 there when we're going through and doing it. So that's the answer to part B, because on part B it said work out what k was as a rational constant, so in other words as a fraction. We've managed to do that. Part C, justify by further differentiation that this value gives the minimum. Okay, yeah, well, if you're good at these, this shouldn't be any problem to you at all. If I want to show it's a minimum, I'm going to differentiate again, sub it in, and hopefully it'll work out to be, for a minimum, it'll work out to be a positive value. But let's go ahead and do it. So d2s by dh squared, first of all, is going to be differentiating that one again. So multiply by the power, take one off the power, minus 2, sorry, let's just make it clear what we're differentiating. We're differentiating this function here. So multiply by the power, makes that 500,000 now. Take one off the power, h to the minus 3. Multiply by the power, minus 500. Take one off the power, h to the minus 3 over 2. So that's my expression for d2s by dh squared, and I just need to sub in my value from before, which was 250 to the 2/3. So we're just going to plug that in now for both of those terms there. Take a little bit of time to do it. It actually works out to be, when you do that, you're going to need to take some time to do that, but I've already previously done it. Works out to be 6. Don't care that it's 6. I do care that it's greater than 0. Therefore, it's a minimum. Okay, so not a bad end to the paper there. Some not very nice algebra to do, but the basic concepts of that one should be okay to you. Hopefully that will make sense.